In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence.
In the distant corners of our solar system, ice giants Uranus and Neptune are violent worlds. Blanketed with smoky hazes, these outer planets are frenzied, turbulent, and unpredictable. Neptune claims the fastest winds in our solar system. Like an apparition, its great dark spot surfaces and vanishes without warning. Uranus's inner swarm of moons dash around the planet in less than a day, and collisions are unavoidable. The most controversial of the far-off planets isn't even a planet anymore. So why was Pluto demoted? Among our planets, Pluto was long considered to be a bit different. Much smaller than the rest, it has the largest moon in proportion to its own size. It also has the most inclined and eccentric orbit.
Its orbit is sort of shaped like an egg. Pluto's orbit causes it to get significantly closer to the sun and then further away from the sun.
This cosmic needle in a haystack eluded planet hunters for decades. The eighth planet, Neptune, had been discovered in 1846, and astronomers at the turn of the century were convinced there was a ninth planet in the far reaches of our solar system. Although it later proved to be smaller than our moon, Pluto was originally thought to be as large as Mars. So Tombaw's discovery was anointed as planet number 9.
No one really thought much else about it. It was a strange object. It was sort of this lonely oddball at the edge of the solar system, but nothing else to call it, so it was called a planet.
At its closest, Pluto is 2.7 billion miles from Earth. Its diameter is 1,485 miles, half the width of the United States. It takes 248 Earth years for Pluto to orbit the Sun. And a day on the planet is equivalent to about 6.5 Earth days. A 150-pound Earthling would weigh only 10 pounds on Pluto. It's a testament to modern technology that we know anything at all about the surface of Pluto.
We can hardly see this thing. Even with the Hubble Space Telescope, we get maybe 4 pixels across, maybe 12 pixels total. But even with that, we see that parts of Pluto are as dark as coal, and parts of Pluto are as bright as snow.
Even from afar, scientists can measure the composition of the planet. They believe that the bright areas of the surface are made up of 3 types of ice.
Well, one is carbon monoxide, one is methane, which is the same as natural gas. And then the third is nitrogen, the same stuff that we have breathing here in our atmosphere.
The dark areas are probably solid rock.
The darker areas are almost certainly silicates of some sort. Silicates not unlike the rocks that we see here. That means there's silicon in them and there's oxygen in them. We're up here in Rocky Mountain National Park in Colorado. There's some snow around, there's some rocks around. This is similar to what we're going to see on the surface of Pluto.
A traveler to Pluto would find that despite the snowy surface, it is a very dim place.
About 30 or 40 times further away from the sun than the Earth is. This means that the sunlight hitting the surface of Pluto is about 1,000 times fainter than it is on the Earth. It's maybe about the same brightness as being outside under a dim street light at night. You could probably You know, you could take a book, you could probably read it there. Take a headlamp though, take a flashlight, it'd help out.
Its distance from the sun also makes Pluto one of the coldest places in the solar system, with a bone-chilling average temperature of -388 degrees Fahrenheit. And because of its small size and low density, gravity on Pluto's surface is far weaker than on Earth. As the early protoplanetary disk of gas and dust in our solar system settled, Jupiter and Saturn gathered up the most material and became the largest of the gas giants. As Jupiter and Saturn's orbits grew, they destabilized the planetary system as a whole. Dynamic interactions pushed Uranus and Neptune outward to the edge of the solar system at an accelerated rate, where they feasted on icy objects.
They have a lot of that initial gas, but they also gathered a lot of icy material and some rocky material in their formation. So consequently, although they have this surrounding envelope of hydrogen and helium gas and some methane, some nitrogen, some other stuff, they also have a lot of icy material in the inside.
These icy interiors have led some to call Uranus and Neptune the ice giants. But it's incorrect to imagine them as balls of solid ice that an astronaut could walk across.
Well, if we dropped an astronaut or a probe towards the center of Uranus or Neptune, well, first of all, they'd be in a lot of trouble. There's really no solid surface that they could stand on. There may be a small rocky core at the center of these planets, but the pressure that they would be experiencing from the atmosphere overhead and this liquidy, icy region would crush them. It would be millions of times the pressure that we have from our own atmosphere, for example. So they would be flattened well before they ever reach the solid surface.
While the other gas giants have wild weather patterns, Uranus seems to be relatively calm, and scientists think they know why.
Uranus is unique among the gas giant planets in that it is the only one that doesn't have an internal heating source. Jupiter, Saturn, and Neptune all have heat coming from deep within the planet, and that helps drive the circulation. And it explains why we see a lot of the banded structure that we do on those other three planets. Uranus doesn't have this internal heating source.
Unlike Saturn's thick icy rings, Uranus's are dim and thin, comprised of dark, rocky dust. Some of Uranus's dusty rings were likely formed by the impact of a meteor or a comet with one of the planet's 27 moons. The inner rings could be the result of collisions between the moons themselves, especially the 13 that orbit in the planet's kinetic inner swarm.
There are a lot of inner moons around Uranus, moons that are very small and close to the planet. They tend to have very fast orbits on the order of maybe a day.
Other moons zip around Uranus in just 12 hours. By comparison, our moon circles a planet 4 times as small and takes 28 days to do it. Uranus shares the outer solar system with its sister planet Neptune, a gleaming sapphire some 3 billion miles away from the sun. With the demotion of Pluto, Neptune is now our outermost planet. Neptune takes its name from the Roman god of the seas. Neptune is 2.68 billion miles from Earth. Measuring roughly 30,000 miles, Neptune's diameter is 4 times that of Earth's. A year on Neptune is equivalent to 165 Earth years, and a day lasts 16.1 hours. If you weigh 150 pounds on Earth, you would tilt the scales at 169 pounds on Neptune. Like all the outer planets, Neptune rotates much faster than Earth, and this rapid spin helps to create violent winds.
In fact, the highest winds recorded on any planet in the solar system are on Neptune. You have winds of sometimes over 1,000 miles per hour, and commonly 750 miles per hour, raging in that upper atmosphere. And we're not quite sure why, so there's a little bit of mystery.
What puzzles scientists is why Neptune's winds blow even stronger than those on the other outer planets, with speeds 2 to 3 times faster than in Jupiter's blustery Great Red Spot. JPL researcher Michael Mishna studies what drives weather on other planets. He's intrigued by Neptune's mysteriously strong winds.
If we were to put one of these windmills up on Neptune, depending on the altitude that we put it, we would either see motion similar to what we see now, or if we were to place it at the altitudes in which the winds are going 1,000 miles an hour, we actually might not see very much motion at all. And that's because the atmosphere is so thin that there's just not enough oomph and not enough force from that wind to actually turn the propellers of the turbine. So you might not actually see any motion at all. On Earth, we see high pressure and low pressure systems if we look at weather maps, and the same to an extent can be seen on the outer planets. We can't exactly identify a big H in this location or a big L in this location. But there are generally regions that are warmer and have higher pressure than other areas which are colder and may have lower pressure, and that generates the winds that blow from high to low.
A key factor in the creation of wind is an energy source to heat the air. On Earth, the sun provides this energy. But the windswept planet Neptune is 30 times farther from the sun than Earth, and it gets only about 1/900th as much solar energy. It's simply not enough to power Neptune's colossal winds. Scientists believe that Neptune gets its additional power from within. Measurements taken by Voyager 2 showed that Neptune radiates twice as much heat from its interior as it gets from the sun. The highest ratio of heat outflow to inflow of any planet in the solar system.
Neptune has a relatively large amount of internal heating, which is coming from radioactive decay of materials inside and other chemical processes that are occurring, and that releases a lot of heat from the inside.
Just why the interior of Neptune generates so much heat remains a mystery. It's led some to speculate that the planet is still in the process of forming, and the infalling gases are releasing heat as they are compacted by gravity. This internal heat source could also explain the convection of gases in Neptune's atmosphere that leads to fascinating cloud patterns.
There are many bright white clouds that appear in the atmosphere. There are different regions of very bright and dark banding on the surface, so we'd be able to distinguish different latitudes by the brightness of the bands.
Scientists believe that the banding patterns have something to do with Neptune's cloud composition.
These are probably made of methane, and they move very fast around the planet as well.
Neptune's wind movement is unlike anything we are accustomed to.
These are giant storm systems. Storm systems that would dwarf anything that we see on Earth.
In 1989, Voyager 2 snapped a photograph that shocked the mission scientists. Neptune had a huge storm, a great dark spot in its southern hemisphere. Stretching 8,000 miles wide, large enough for our Earth to fit in the center, the storm resembled Jupiter's infamous Great Red Spot.
The Great Red Spot is a huge anticyclone, which is fed by many smaller storms that keeps it alive, if you like. Otherwise, it would dissipate and disappear. In the case of the Great Dark Spot, we believe it's more of an instability in the atmosphere, which rocks back and forth because of the flows in that very fast atmosphere.
Just 5 years after the spot was first discovered, scientists were in for another surprise. The Hubble Space Telescope turned its eye toward Neptune, only to see that the largest storm on the planet was gone. happened to Neptune's great dark spot. Within a span of 5 years, the largest storm on the planet simply vanished from the southern hemisphere. But that didn't mean the end of megastorms on Neptune. Astronomers using the Hubble Space Telescope observed that a new great dark spot had appeared. But this time in the planet's northern hemisphere.
It seems that on Neptune, the storm systems that manifest as these big spots you can see with a spacecraft or a telescope, they sort of come and go on shorter time scales than, say, the great red spot on Jupiter, which has been there for hundreds of years.
Not only are these storm systems transient, they're also eccentric. Scientists observed that the size of the great dark spot oscillated by several thousand square miles within a span of just 8 days. The disappearance and reappearance and overall erratic movement make Neptune's storm systems some of the most unpredictable in the solar system. Similar to its outer planet neighbors, Neptune has a complex system of moons. 13 have been discovered so far.
There are 8 planets that orbit our Sun, but did you know that they can be separated into 2 groups? One group includes the 4 planets closest to the Sun: Mercury, Venus, Earth, and Mars. These are known as the inner planets or the terrestrial planets. The other group of planets, categorized as the outer planets, contains the 4 planets farthest from the Sun: Jupiter, Saturn, Uranus, and Neptune. The inner planets and the outer planets are separated by the asteroid belt. The asteroid belt is a region of asteroids orbiting the Sun between Mars and Jupiter. Although each of the 8 planets have distinctive features, there are trends that categorize the inner planets and the outer planets. Inner planets are smaller in size than the outer planets. Mercury is the smallest inner planet with a diameter of 3,031 miles. The outer planets are much larger, the largest being Jupiter with a diameter of 88,846 miles. Another differing factor between inner planets and outer planets is that inner planets have solid surfaces and thin or no atmospheres. In theory, it would be possible to stand on each of the inner planets, although you would only survive on Earth. The outer planets are all made of gas, although scientists believe that they might have a much smaller or liquid center. Anyway, it would be impossible to stand on any of the outer planets. Inner planets are different from outer planets because they have greater density. The elements in the inner planets are more closely packed together, causing them to be smaller. Despite being larger, the elements making up the outer planets are less densely packed together. The atmospheres vary among the inner planets, where the atmospheres in the outer planets are all the same. The contents of the atmosphere of the inner planets vary from planet to planet. Mercury has no atmosphere. Venus's atmosphere is mostly carbon dioxide. Earth's atmosphere is mostly nitrogen. The outer planets generally have all the same atmosphere, which consists mostly of hydrogen and helium. Inner planets orbit the Sun at a faster rate than outer planets. As we know, Earth takes about 365 days. The outer planets are millions of miles away from the Sun. Therefore, they have a much greater distance to cover to complete one orbit. Neptune takes over 164 years for it to make its way all the way around the Sun. Inner planets spin slower compared to outer planets. Earth rotates on its axis the fastest at 23 hours and 56 minutes. The outer planets spin faster. Jupiter spins the quickest in the solar system. It only takes 9 hours and 55 minutes to rotate once. The inner planets have fewer moons than the outer planets. As we know, Earth only has 1 moon. Mars has 2, and the rest of the inner planets don't have any moons. All of the outer planets have many moons orbiting them. 63 no moons orbit Jupiter. Moons aren't the only features surrounding the outer planets. All of the outer planets have rings orbiting them. The rings are thin disks of dust and rocks. Saturn has the most visible ring system of any of the planets. None of the inner planets have rings orbiting them. Although each of the planets in our solar system are unique, they can be split into two groups, inner planets and outer planets. With further space exploration, scientists are sure to find even more differences and similarities between planets. Will you contribute to the exploration of our planets?